2 times the absolute value of x plus 3 minus 4 if x is less than or equal to negative 2. Negative x cubed plus 1 if negative 2 is less than x is less than or equal to 1. And 5x minus 3 if x is greater than 1. Monday night, we did those very basic piecewise defined functions, just with our 8 special functions. Now that we know the shifting techniques, we can look at more complicated piecewise defined functions. Times the absolute value of x plus 3 minus 4. We know what absolute value looks like. What does the minus 4 do?
Down 4.
So down 4.
0, 4.
What does the plus 3 do?
Shift right.
That's
Left.
3. That's our turning point. And the 2
Goes up.
Shifts it.
right.
Stretches. As it goes next to it.
Once again, I don't want the whole thing. I want the piece where the x values are less than or equal to negative 2. There's negative 2. I want less than or equal to that. And we do need to find that endpoint. If x is negative 2, what's y?
Negative 3.
Negative 3.
Don't rely on the graph to tell you. Negative 2 plus 3 is
0.
1. Absolute value of 1 is
1.
1. 2 times 1 is 2.
2.
Minus 4.
Negative 2.
Negative 2. Second piece. Y equals negative x cubed plus 1. You know what x cubed looks like? What does the plus 1 on the outside do?
Shift up 1.
And that one,
Up
don't
one.
find the other point too, because one thing is less than negative 2. There's another negative 2 point.
No, it's the x value is less than or equal to negative 2. And that's the only negative 2 point. All right, what does the plus 1 on the outside of the cube function do?
0, 1.
Up 1. And what does the negative do?
Flip it.
Turns it upside down. But I don't want the whole piece. I want the piece between negative 2, 1. At negative 2, what point are we at?
8. 9.
Negative 2, what point are we at?
9.
9?
How'd you get that?
Well, what's negative 2 cubed?
8.
Negative 8, and then take the opposite of it, so it's positive 8.
Plus
Plus 1 is 9. All right, at 1, where are we at?
1 cube.
0?
0.
Last one. Y equals 5x minus 3. What does that look like?
Linear.
Line. What's the y-intercept?
0, negative 3.
0, negative 3. What's the slope?
5.
5, so up 5, right 1. Together. And I want the piece where x is greater than 1. And if I plug in 1 there, what do we get?
1, 2.
Put the pieces together on the graph. shape, it looks like that. New piece that looks like that. A slant. So it's a combination of the piecewise defined functions and all those shifting techniques that we talked about last time. All of that rolled into one problem. Last thing from this section